Hello everyone, welcome back to the MCP series where we are exploring the model context protocol in a step-by-step manner. Um, we have been exploring MCP servers over the last few videos. Very specifically, we have explored two out of the three main components of our basic core components of MCP servers, namely tools and resources, both static and dynamic or template resources. We will start looking into the prompts in a bit, but before we start looking into prompts, let's try to utilize the information or the understanding we have gained about MCP server tools and resources to try and come up with a real world use case of MCP servers as we discussed in our last video. And the example we'll be working on today is trying to create an MCP server for an MSSQL DB instance. So for that, the first thing we'll do is let's just create a subfolder in the root called MCP SQL, or rather MCP MS or MSSQL MCP, right? And then we create a init.py inside it. Let's go through what we have here. So we see that this MCP, so actually let's first pause for a bit and think about what this MCP server, how could we design this MCP server, right? What are the main components of this MCP? What could be the main components of this MCP server? So the main components of this MCP server is one, it should be able to query the database in the sense that, so if you think of it in the terms of client and server, the user will enter a natural language prompt to the MCP client. The MCP client, which will be using an LLM, will then translate that natural language prompt into like some SQL query. And now that SQL query would be passed back to the MCP server, which would then would have to execute that SQL query. And so our MCP server would need to have a functionality, a tool to execute a SQL query, right? Then it would need to have this, well, I should have talked about this earlier, but it should also have the server file itself, the server.py file, right? Like which will invoke the MCP server itself. It needs the tools, and it also needs resources in the sense that when it is working with SQL queries, it's easier to come up with the SQL queries when you have understanding about the tables in the database, what tables are there, and how the tables look, like what columns do the tables have, the data types of each column, so on and so forth. That helps the LLM. So we need to have a mechanism that exposes this data to the LLM on the MCP client side when it is trying to come up with the SQL query from translating the natural language prompt entered by the user. So again, like this immediately points us to resources, because as we discussed, resource is nothing but a data or some way to pass context to the LLM using some structured data, right? Some sort of structured data. So that again, like if we go back to the init.py, like that's what we're talking about here. We have our MSSQL MCP resources, we have the server, and we also have the DB service. What is the DB service? It's essentially just the application, the database application layer, which is the actual layer interacting with the database, right? So let's start with the DB service. Let's create a new folder called DB service. And then under DB service module, so let's quickly create the init.py, but under DB service module, we'll have two files. One is connection.py, which will handle connecting to the database, disconnecting and all that stuff. And the other will be queries.py, which will handle all the various sorts of querying. So again, just like what we have been doing in previous videos, I'll be copying over most of this stuff from work already done. But we'll go through each and every section of the code basically. So quickly, let's go to connection. Let's quickly copy it over here and let's see what's happening, right? Connection is nothing but, now we have this db config. Now ideally you would be passing it using an environment variable, and that's what I'll do later, but right now we have this db config, and then we're creating a database connection class, and that class has some class functionalities. It has a get connection, which allows it to get the connection using the details that we are passing it as part of the db config dictionary. And then it has some other functionalities. It tests the connection, and then yeah, that's more or less it. And then, so this is related to connections, connecting to the database. That's it. Now we have the queries.py. What does queries.py do? It is responsible for handling any sort of query to the database. It is responsible for actual execution of the SQL query. So in this service, in this file, you will find functions like get all tables, which returns a list of all the tables, execute SQL query, which executes a SQL query. And we will see later that these functions are later implemented via the MCP protocol. So for example, we have this get all tables, which we'll see in one of the MCP resources, which schema/all resources, which uses this function to get back all the tables present in the MSSQL database that it connects to, so on and so forth, right? And then later, finally, we have the init.py, and then init.py, we can also just quickly copy paste. Init.py has one function that I want you to take a note of, which is the get table schema. So get table schema is again used by the resource schema/table name. It's the same resource, which is a parameterized or resource template. And this get table schema, what it does is nothing but, so get table columns, get table primary key, all these functions are defined. If you check the connection.py, all the functions are defined here. And in the init.py, we have this new function get table schema, which basically gets details from all these individual functions and combines them into a single database, which is then passed back as the resource output, right? So now that we have the DB service set up, let's first look into the actual server.py, right? So let's create the file, and again, just to quicken up the process, what we'll do is we'll just go here and more or less copy everything. Now in our previous work, we already had one prompt included, so we'll just ignore that for now. But other than that, we'll mostly copy over everything, and then we'll just add the main block, and that's it, right? We just paste it quickly. Sorry about that. All right. So let's quickly go through the server.py file. What is it actually doing? Let's remove this. Right. So very quickly, we see that this MCP server is supposed to have two resources: one static server info, which we have already played around with, worked with, and then the other is a template resource, which is schema/table name. We'll come to it in details later, but the idea is if you pass in all, you get back the table names of all the tables in the database instance, and if you pass in a particular table name, you get back table specific details for that particular table, right? And then we have one tool available, which is execute SQL query, which actually executes the SQL query. Now, if we look in the import statements, we see that from DB service, we are importing the actual execute SQL query functionality. So very, again, like just to go over, we have this MCP server, which has this tool. Again, like if we look in the import statements, it's importing execute SQL query from DB service module. Now execute SQL query is, as I said, it's defined in the init.py of the module. And if you go through the service, it's nothing but it's basically like getting the execute query function from the connection.py, and that's how it is. Yeah, execute query from connections.py, and that's how, and if you look at this function, that is the one that is actually executing the query, right? So let's go back to the server.py, and then we see we are defining the execute SQL query as an MCP tool. We have this beautiful description which tells the MCP LLM client how to use this tool, and then we have the actual tool itself where it gets some db config. Again, like this get db config is also defined in the init.py. And finally, it executes the SQL query, DB execute query. So if you look at the import statement, you will see that it's execute SQL query is being imported as DB execute query. That's simply it. So it executes the query, and if it sees an error, it prints out this error statement or returns this error dictionary. So that's how the execute SQL, or rather the tool is working. And now we have the resources. So what we can do is new folder, MSSQL MCP resources. Before that, what we can do, MSSQL MCP resources. Okay, yeah, this was actually already created because I copied over, but this will be used now. So you can see, just like when we had explored resources earlier, we have this registered all resources function. So we're basically going to do the same thing, right? So let me just rename this correctly. MCP, right? And then we'll have first init.py, and then we'll have a resource 1 and resource. Let me just copy over because we have already had other videos to talk about this in details, right? So we can just copy, paste, right? So resource 1 static is again nothing but like what we had earlier. We'll have two resources. One is this static info and one static resource, and the other is the template resource. So we have two resources, one tool. That's it. And then let's get our second resource, which is the DB schema. So we can just copy paste it quickly, right? And then DB schema resource. So as I said, this is a template resource. If you pass in schema all, if the variable is all, then it gets back all the table names. And so if you quickly go through it, if table name dot lower is equal to all, it will get all tables. So if you look at the module, the database service module, you can see that this function basically gets back the table names of all the tables in the database. And otherwise, if you pass in a table name, it first validates, again, like all these functionalities are from the DB service, but it first validates if the table actually exists. And if it sees that the table exists, it gets the get table schema. It calls the get table schema function, which is again defined in init.py. And as I had shown you earlier, this is nothing like this function, get table schema function, is nothing but it's executing a bunch of other sub functions which are already defined in queries.py, which is getting table relevant information and then combining all that into a single dictionary, which is then passed back as the table schema details, right? So this is mostly it. What we are remaining to do is like copy over the init.py details. Again, like just to keep things simple, I'll just copy paste it, right? And just like before, we have this register all resources function, which is being called by the our MCP server, and under that we have these two resources being registered, right? Perfect. Okay, now that we have all our components, we have the server.py, we have the resources, and we have the DB service. Let's try to run the MCP server now. So the first thing is always to see if we can start the MCP server. So let's go into the correct location, SQL MCP, and then uv run python server.py, right? It says no module named MSSQL MCP resources. MSSQL, okay, we have to rename this into MSSQL, or we could have renamed it there on the server.py, but just keeping this consistent with all our other folder naming conventions. And let's run the folder, and yeah, we can see that the MSSQL MCP test server has started. It has two resources, and that looks like it's working perfect. Okay, now let's quickly test it out with our TUI gadget, right? Tool gadget, whatever you want to call it. So we can do uv run pmap TUI. That will start up the tool. We do need to add the server. So what we'll do is MSSQL MCP Server stdio, then uv, then run Python, then MSSQL MCP /server.py, right? And then we click on add. Okay, and now we try to connect, and it works as expected, and we see we have 2 resources, and we'll see we have 1 tool, right? That's the full tool. And if we quickly check the raw interactions, just like we have always done before, we will see that the moment the server connected to the client, it made all these requests, and in response it got back all the list of prompts, resources, tools that is available in the server, right? Along with the descriptions that tell it how to use it. So now if you want to check how to work with this client servers, whatever, let's try using the resource first. So let's pass in all read resource, and let's see what it's saying. So I created the file. Let's try and read it. Cat MCP resource M4, right? And so we see all the table names here. So now we can do a quick, what we'll do is we will have this, we'll copy over a table name from the list of tables returned, and then we'll pass in the specific table name now, right? So database table name read resource. So again, it read the resource. Let's see what it's saying. Rather MCP resource RT, right? And now we see that we have the table details for the worldwide importers.application.cities, that specific table. So now that we have tested out the resources, and we saw that both the all and the particular table name is working, now let's use that. Now let's use the tool. Let's check out if the tool is working. So I have a query already copied, select count star as total customers from this particular table, and I just click execute tool, and we see that it executes successfully, and it gets back the result. Total customers is 663. And so now we have a MCP server which has a tool to execute SQL queries, and which has access to 2 resources. One is static resource, which gets back details about the server, but the more interesting is the template resource, where if you pass in all, you get back a list of all the table names, but if you pass in just the table name, you get back details about that specific table. Now in the next video, we will see we will start working with MCP clients, and we will see how we can build the actual MCP protocol in totality using both the server and the client side, and how users can then use natural language prompts via the MCP clients to use the MCP server to work with the database as needed. But for now, I believe this is a good place to end. Thank you everyone. Cheers. Bye.